Hello and welcome friends. In this particular module, I am going to speak about vertical distance measurement. We will be covering some basic terms involved in consideration with leveling. Also, we will speak about the construction of the level, its uses, and temporary adjustments and the kind of the readings that one is expected to take in the leveling. As you learn the content, I expect you to define basic terms employed as well as explain the construction and use of dumpy level in leveling. Also, state the kind of readings that are taken by using level. We discussed about surveying. Surveying is nothing but art of determining relative positions of the various points on, above, or beneath the surface of the earth. It is kind of wholesome term. There can be lot many operations that can be conducted under surveying. In the similar way, we can treat that this leveling is a branch of surveying which simply deals with measurements in vertical plane. So the basic objective is to find the elevations of the given point with respect to the datum, as well as to establish certain points at a given elevation or at different elevations with respect to datum. Just to name a few applications, this can be employed to prepare the topographical map, to construct longitudinal as well as cross sections of the terrain, to compute the earthwork involved related with the various engineering assignments, to plan, align, layout of various engineering projects such as road, railways, water supply, sewerage and similar. Also, it can be employed to establish the gradient as well as to check the gradient and reduce level of various stations. Let's try to understand about the basic terms. The first definition is of level surface. The earth is not exactly sphere. It can be treated as some spheroidal surface so as to define certain surface parallel to this particular assumed mean spheroidal surface. Such surface is nothing but level surface. So here, as you see, these particular curved lines are assumed to be parallel to mean spheroidal surface of the earth, and hence these are level surface. Any line which is lying in this particular level surface is nothing but level line, whereas any plane which is tangential to this particular level surface is nothing but horizontal plane. Any line which is lying in this particular horizontal plane can be treated as horizontal line, whereas the direction given by gravity, which is nothing but the line which is perpendicular to this particular horizontal plane, horizontal line, and is directed towards the center of the earth, can be treated to be vertical line. In surveying, The level surface is treated as datum as well as set of horizontal plane and vertical plane are basis for defining the horizontal angles, vertical angles, or any such basic surveying measurement the way we discussed previously. So here the datum can be treated as the surface which can be referred in order to express the vertical ordinates. Generally, any point which is to be set with certain level or to be measured with respect to the data is to be expressed as certain elevation or reduced level. Here, as you see, this is horizontal line, whereas this is also another line which is also horizontal in nature, but the angle which is made with respect to this horizontal plane in vertical plane in elevated or depressed manner is nothing but vertical angle. Mean sea level is another criterion which is nothing but the average height of the sea surface. Here this is obtained by observing the existing sea level over 19 years. Benchmark is relatively permanent point which is treated as reference for the determination of the reduced level of the various points, and it is established with respect to the data. As far as leveling is concerned, any point which is to be measured with respect to the data or which is to be established with respect to the data is called as station. Let's speak more about the benchmarks. So, in simple terms, benchmark is nothing but point of known elevation. As we discussed previously, elevation is nothing but the reduced level. It is nothing but the height of that particular point with respect to the datum. This benchmark can be classified under 4 categories. The first category that you see is nothing but Great Trigonometrical Survey benchmark. It is commonly abbreviated as GTS benchmark. Here, this point is very important point as far as referencing is concerned. The most important category of the surveys, like geodetic survey, that too the first order triangulation, needs to be referred and needs to be conducted in order to deal with the GTS benchmark. This is basic network of the benchmarks. With respect to this kind of the network, some other government agencies like Public Works Department can refer the another network, and such stations, such reference points are nothing but permanent benchmarks. As well as while carrying out some ordinary surveys, one may choose some reference point whose elevation is arbitrarily assumed in order to conduct the leveling operations. It is not referred with permanent benchmark or GTS benchmark, and hence it is treated as arbitrary benchmark. As we carry out this leveling work, We start the work from benchmark and we are expected to close our work at the benchmark. But because of some other unseen reasons or some common reasons, we have to take break, say for example, then under such circumstances, we take some semi-permanent kind of object to close the work, from which the work will be restarted subsequently after taking the break. Such benchmark is called as temporary benchmark. Here on the right side, you see the chain of these particular triangles. As you know, it is nothing but the triangulation network. So, with reference to these particular set triangulation networks, one will be establishing the network of these GTS benchmarks. And such data is available with the Survey of India as well as various government organizations in order to start the work. In some regions, to locate such permanent benchmark, to locate these particular GTS benchmark, can also be taken as important work, and some people look towards these as their hobby. Here what you see is nothing but the variety of GTS benchmarks established at various regions. It is permanent structure and it is always treated as certain monument. So these are kind of brass or metal disc which is fixed in this particular ground, and it provides the basic coordinates, maybe latitude, longitude, but certainly the orthometric height, that is nothing but the reduced level of that particular point. So here, as you see, here the elevation above sea level is provided here. So here these particular GTS benchmarks provide reference for establishing network of the permanent benchmarks for second as well as the third order of the triangulation networks. This kind of the benchmarks indicate the height the way I mentioned earlier. In order to carry out leveling, the basic equipment that we use is known as level. In order to carry out such a leveling work, there are number of levels like dumpy level, tilting level, automatic level, Y level, Cook's reversible level, Cushing's level, digital level, etc. Depending on the kind of speciality it has, the level can be recognized. We'll be speaking more about the dumpy level as we proceed further. Just to understand the few of the differences, tilting level is provided with telescope which can be tilted in vertical plane. Automatic level is provided with some kind of a compensator which works on its own to make the line of sight horizontal in some range of the tilt. Here in Y level, the telescope is detachable and it is supporting over two supports which are Y in shape. The Cook's level is nothing but the reversible level and it combines the features of dumpy level and Y level. Here the telescope is supported by two rigid sockets into which the telescope can be fixed. Cushing's level, here also the telescope is fixed, but eyepiece and object glass can be detached and it can be interchanged end to end. This is the most modern type of the equipment that is available today, that is nothing but digital level. It has the capacity to measure the distances, record the distances, and it is quite precise also. During the lab sessions, you will get more acquainted with the range of type of levels that are simply mentioned here. For category of the levels, mostly the constructional aspects are similar. That's why let's speak about the construction of this particular dumpy level and the main components to understand the usage of the level. Let's see from the bottom. Here, this is the tripod stand on which the leveling head is provided, which consists of two triangular shaped plates separated by 3 or 4 leveling screws. The upper plate is called as try branch, whereas the lower plate is called as trivet. The screws are called as leveling screws. Centrally, there is a provision of the spindle on which the telescope and related components are assembled. This is the telescope. On one end there is an eyepiece, at the other end there is an object glass. The telescope is provided with a focusing screw as well as longitudinal level tube and cross bubble tube. In order to avoid the direct entry of the sun rays, it is also provided with ray shade. Some dumpy levels are equipped with some circular compass, which also facilitate observing the bearing of the survey lines. It is an additional feature. It is not essential feature as far as level is concerned. The lower part shows the actual image of the dumpy level. According to the manufacturer, some small changes are possible, but mostly the kind of components that we have considered here are applicable as far as constructional aspects of dumpy level are concerned. There are some small items which are worth considering. Here what you see is nothing but the clamping screw. Here, whenever we wish to have the equipment clamped in certain direction, we make use of this. In addition, it is equipped with some kind of screw which is called as tangential screw, so that we can have the slow movement of this telescope. Here what two dots that you see are nothing but the position of diaphragm. Some small things related with other constructional aspects we'll be discussing as we move further and as we understand the adjustment and usage of this level. The longitudinal level tube is the uppermost portion. It has got variety of the patterns. The constructional aspect can be more elaborated here. It is fixed at one end, whereas other end is flexible. It is provided with capstan headed screws so that it can be moved up or down with respect to the horizontal line. This is actually level tube. Some non-viscous liquid is filled in it with portion of air trap so that it acts as bubble. The movement of the bubble decides the sensitivity of that particular level tube, as well as it facilitates the leveling operations. There are a range of the equipment which are providing the circular level tube, which is also called as pond level. Here, what you see is nothing but compass. At this particular portion, the circular disc that you see is nothing but the compass, which facilitates the operation of taking the bearings. The lower portion shows the arrangement of leveling screws. Here you can see the clamping screw and tangential screw in order to have the smaller movements of this particular telescope. This is the tripod and variety of tripods. Here you can see the lowermost portion that is provided in order to assemble the upper body of level. Dumpy level being compact and usage wise easy, even it is quite sturdy, it holds significant importance in surveying operations. It is mostly preferred choice of surveyors. It performs the leveling on a construction site to set the positions or to determine the positions in vertical plane. It is very useful to measure the height as well as the distances of different locations in surveying operations. It is also useful to set out some inclined surfaces during the constructional activities. It is also the basic equipment adapted to plot the contours on site during the contouring operations. Usage wise, we have to work strategically with the level. The first part is deciding the location or position of the level. Here one must see that equipment will be stable, it can be established firmly, there won't be much of the disturbance, as well as it will establish large control over the area to be surveyed. Normally what we do is, first we fix the tripod by making use of the pond level provided on it, and accordingly we mount the equipment on the dumpy level. As we mount the dumpy level, then by making use of the legs, we bring the bubble of the center, bring the bubble of longitudinal level tube at the center by making use of legs, and then we make use of leveling head in order to level the equipment. We have to take certain precautions while setting the dumpy level. So here one must see that the position of the bubble will be remaining at the center for the entire time that we wish to take to carry out the leveling work. One must see that the tripod is adjusted till the appropriate height. One must not simply touch or apply pressure on the equipment while taking the readings. It is also good practice to keep on checking the position of the bubble after every reading. Every level is to deal with the horizontal plane and hence the vertical plane. In order to decide this particular horizontal plane, we take a reference of the direction of the gravity, which is nothing but the vertical axis of the equipment. So this level is to have some specific axis, the way I have mentioned here. Firstly, axis of telescope. It is the line joining the optical center of the objective and the center of the eyepiece is nothing but the axis of telescope. As we discussed previously, there is a provision of longitudinal level tube mounted on the telescope. So when the bubble is brought at the center, a line which is tangential to that particular bubble will be horizontal, and hence this line is called as axis of level tube. A line which is joining the intersection of the crosshairs of the diaphragm and the optical center of the objective and its continuation is called as line of sight. Practically, the line of sight and axis of telescope are overlapping each other. They are parallel to the axis of bubble tube. As well, they are perpendicular to the vertical axis of the equipment. The vertical axis of the equipment is passing through the spindle of the equipment. It is in the direction of the gravity. Practically, the level rotates above the vertical axis in the horizontal plane. As we set the equipment, as we establish position, the level, we have to carry out certain adjustment to establish the requisite relationship among the axes, the way we discussed previously. In order to do so, the adjustments which are done at each of the stations are called as temporary adjustment. These need to be carried out in specific sequence, like setting the equipment, leveling the equipment, and thirdly, focusing of eyepiece and object glass. Sometimes some of the equipment are provided with just pond level or circular bubble tube as it is called. So this can be brought at its center the way represented here in this particular figure. Both A and B leveling screws can be moved in the inward or outward manner according to the requirement, so that the bubble will be brought in the direction of the remaining screw. Then this remaining screw can be moved in the inward manner or outward manner, so that the position of the bubble will be coming exactly at the central ring. As we do so, we can assume that the equipment is leveled. Mostly, the Dumpy level is provided with longitudinal level tube on the top of the telescope. So in order to have that leveled, we have to follow a proper sequence, and just we have to make use of these particular leveling screws as they are mentioned here, A, B, C. After mounting the equipment on the tripod, we have to bring these particular leveling screws at the center of their run. Then bring the bubble tube parallel to make the telescope parallel to these 2 foot screws or set of any 2 foot screws, so that by rotating these leveling screws either in the inward manner or outward manner, the bubble will be brought at its center. As the bubble is brought at the center, Now the telescope position will be such that it will be lying on that particular remaining screw. That is, the telescope will be perpendicular to its earlier location. Here in the lower part of the figure, what you see is nothing but the telescope made parallel to any 2-foot screws, whereas the vertical direction of this particular telescope indicates that it is brought to its second position so as to make the axis perpendicular to its earlier position. So by making use of this third foot screw, now bring again the position of the bubble at the center. So as you do so, again you have to go for the first position. Check whether the bubble is remaining at the center. If not, repeat these particular 2 steps twice or thrice so as to bring the bubble at the center for both the positions. Then turn the telescope end to end and see whether bubble is remaining at the center as it is rotated above its vertical axis in the horizontal plane. For all the positions, if the bubble is remaining at the center, equipment can be said to be leveled, and it can also be concluded that the given equipment is in permanent adjustments as far as the leveling part is concerned. Now, the next part is nothing but focusing of the eyepiece and object glass. Focusing of the eyepiece and object glass facilitate the elimination of parallax. So here this particular parallax is a condition arising when the image formed by the objective is not in the plane of crosshairs. So unless this particular parallax is eliminated, it is not possible to have the accurate sightings. In order to remove this particular parallax, first step is to focus the eyepiece and then focus the object glass. As we look through this particular eyepiece, we'll be seeing the position of the diaphragm, which gives the vertical hair, horizontal hair. Number of patterns are possible, but here what you see is nothing but the vertical hair and horizontal hair, which is referred in order to take the star readings. So here this eyepiece needs to be turned so that the image of this particular diaphragm or the crosshairs will be seen sharp and distinct. In order to focus this particular eyepiece, usually we look towards some clean surface, or we can hold some white paper in front of the objective and the focusing of eyepiece can be done. Next part is focusing of the objective. So in order to do so, as we look through this particular eyepiece towards certain object under consideration, here as we see, it is looking towards certain graduated rod, graduated staff. So the image of this should be sharply and distinctly seen. So as we have this particular eyepiece and object glass focused, now the equipment is ready to take various star readings. So the way I mentioned earlier, this is the arrangement of the diaphragm. What you see is nothing but the vertical hair, horizontal hair. This horizontal hair and vertical hair are each on circular glass piece. We expect always that to be remaining in horizontal and vertical plane. If they are tilted, that can be adjusted by making use of these studs. As I mentioned earlier, this vertical hair and cross hair can be provided in this number of formats. Here, some internal constructional aspect of the telescope can be seen. Eyepiece, position of eye, position of the diaphragm. Here it is nothing but the focusing lens. This is the focusing screw. Then the object lenses. So this particular internal part is not exactly dealing with our leveling operation, but it is just one of the constructional aspects. So we are expected to take some certain readings in leveling. Say we have attained the requisite position on site in order to take the readings. We have carried out the temporary adjustments. Hence, now equipment is ready to take the readings. After carrying out the temporary adjustments, after leveling the equipment, after focusing the eyepiece and objective glass, we can take the reading on a point of known elevation, and such reading is termed as backside reading. Please excuse me, these should be backside, SIGHT. Now, after taking the set of the readings, after dealing with number of points, number of stations, we may be expected to shift the equipment to continue our work, or we may be expected to close the work from the same position. So in order to do so, we take the reading on some last station or convenient point for the temporary closure, and such reading is called as foresight reading. In between backside reading and foresight reading, the kind of readings that we take are called as intermediate sight readings. From a single setup of the equipment, we cannot sight all the stations under consideration. For that, we have to shift the equipment from instrument station to instrument station. To facilitate this, we take reference of certain point which is called as change point. So this change point is the point on which we take both foresight for one set as well as backside from subsequent set. In fact, change point and turning point are one and same, but this turning point terminology is usually used wherever the starting station and ending station cannot be seen from one instrument position, and we have taken certain temporary benchmark from where the work is continued. Practically, we can assume change point and turning point to be one and same, which is nothing but the point on which both backside as well as the foresight is taken in order to continue the leveling operation. So here what you see is nothing but the schematic diagram showing all the kind of the readings. So this is the terrain on which we are carrying out the leveling work. This is the first station. This is the first station, which is nothing but the benchmark. So up to this particular line of sight, line of collimation, the reading taken on the point of known elevation, which is nothing but the benchmark, is nothing but backside reading. Whereas in between, we take the reading at station A, station B. Hence, these are termed as intermediate sites. Now, here this particular station D and E, etc. could have been placed at quite a longer sites. So from this particular first site, we cannot take the reading. Hence, we have to shift the equipment of the point at some other setup. In order to do so, here we adopt some station C. So as you see, for this particular setup, we have taken the last reading, that's why it is termed as foresight. Whereas, as we set up the equipment on some subsequent position, from that, again we take the reading on the same point without altering the position of that particular star, which is termed as backside reading. Hence, the leveling operation involves backside, first reading taken after setting the equipment, foresight, last reading for that setup of the equipment, and number of sites that are taken in between foresight and backside termed as intermediate site. We have to be very careful for this particular station C. It decides the accuracy of the work. We should see that the graduated rod that we keep on this particular station C won't sink in the ground. Its verticality should be maintained at this particular station C, and hence we can keep some, say, metal plates which facilitates the proper holding of the star at that particular change point. So, the graduated rod that we mentioned number of times in our earlier discussion is termed as leveling staff. These are nothing but certain vertical scales graduated with convenient markings to measure the height of line of sight with respect to the ground level and also in relation with the datum. The staffs can be of two types. One is self-reading type, another one is target type. Here, the ordinary telescopic staffs are provided into three scales which slides in one other telescopically. Hence, these are called as telescopic staff. Whereas, the graduations that are marked on these particular telescopic stars may not be fine one because of the precision required. Sometimes, the fractional part of the divisions that are provided in between the graduations could be a requirement, and that's where we can adopt some vernier scale that is fixed over the ordinary leveling star. Such stars are called as target stars. Nowadays, the kind of digital level that we measure, the kind of digital level that we use are provided with some specific staff which is called as bar-coded staff. Here, the surveyor is not expected to take the reading because the equipment on its own records the reading. Here, some graduations can be distinctly seen. The way you see the lowermost portion here for this kind of staff reads 2.90, whereas the uppermost part of this E-shaped letter is 2.95. Exactly center can be read as 2.923. So here these kind of graduations need to be studied, and accordingly the person who is seeing through the eyepiece, the person who is carrying out that particular leveling work need to take these particular readings. Here some another pattern is shown. So the uppermost part of this particular 7 indicates the 0 mark. It is showing the whole complete covered height up to that particular point. Whereas the way you see, the lower part here is 7.21. Then here this portion is showing 7.23. As such, here these graduations need to be studied before taking the reading. This is the another part which is showing various reading. The first half is showing 1.636, second one is 1.5 here, third one is 1.58. Now, as I mentioned earlier, each staff manufacturer may follow their own graduation patterns. Usually, each division is having 5 millimeter width. So, as we look through the telescope, the lowermost portion is to be read as 0.00, whereas the uppermost portion of that particular stream will be read as 0.005. Firstly, we have to take a reading of the leftward figure, which covers the height in meter. Then we have to read the rightward figure, which reads the centimeter, and lastly we have to take the reading corresponding to that particular graduation with respect to whether the horizontal hair is coinciding with the bottom or it is coinciding with the top, so that it will help us to understand that 5 millimeter revision part as such. So this is the general process, but as I mentioned earlier, it may vary from constructional aspects of the kind of the level that you use, as well as the kind of the graduations that are provided on that particular staff. One must be holding this particular staff exactly in the vertical plane. So here, as you see, this is actually the view that one get when one sees through the eyepiece. So this is the position of the diaphragm, showing the horizontal hair as well as the vertical hair. So this vertical hair can be referred in order to decide the verticality of the staff. The staff should not be away from the body or towards the body in tilted manner, but it should be held exactly in the erect manner. In order to understand and ensure the verticality of the staff, we can take reference to the vertical hair, even horizontal hair, but it's better to make use of the pond level that is provided on the staff. It may be provided on the backward side or sideways, but as the person who is holding the staff look towards the position of the bubble, he will be able to understand whether the staff is vertical or not. So this is just preliminary introduction as far as all the leveling aspects are concerned. I hope you have understood the concepts that I have mentioned here. Thank you for your attention. As we move ahead, before entering into the other aspects of leveling work, we will get introduced with the construction and use of compass in land survey. So bye till then. Thank you very much. I wish you very happy learning.